A critical approach to learning science is concerned less with accumulating undigested facts and scientific definitions and procedures than with learning to think scientifically. As we learn to think scientifically, we inevitably organize and internalize facts, learn terminology, and use scientific procedures. But we learn them deeply because they are tied into ideas we have thought through and hence do not have to relearn later. A critical approach to learning science requires us to ponder questions, propose solutions, and think through possible experiments. Scientific thinking is, in short, self-directed, self-disciplined, self-monitored, and self-corrective. It presupposes assent to rigorous standards of excellence and mindful command of their use. It entails effective communication and problem-solving abilities, as well as a commitment to developing scientific skills, abilities, and dispositions. In spite of all these advantages, scientific thinking is only used by science. Through the centuries, it was proven that successful scientists were those who used scientific method. For example, Hubble had his own point of view for scientific thinking. He followed the scientific method and equations in order to reach his conclusions. By following the scientific method, Hubble was able to form what is known as Hubble's law. Also, Galileo was one of those scientists who followed the scientific method. He made far-reaching contributions in astronomy, especially in his defense and promotion of the so-called scientific method. Forever thinking and testing, Galileo would first reduce complex problems to simple terms based on logic. He then approached each individual problem with mathematical reasoning. Though historians dispute his title as the founder of modern experimental science because they argue that experimentation had little to do with his discoveries, Galileo's name will forever be attached to the concept of scientific method. We developed a questionnaire to see whether people use scientific thinking in their daily life, and we transferred every element in scientific thinking into a simple and straightforward question. This questionnaire was subjected to a sample of people of different ages, sex, and education. Here is a small model of what we found in our interviews.
When you face a problem and you are going to set a plan, do you rely on your feelings or empirical evidence?
On my feelings.
Why?
Because I don't know what empirical evidence is.
Thank you.
What I really know about scientific thinking is the same thing that critical thinking. That's all.
Do you apply it in your daily life? Okay. هاي انت تعرف يعني ايه scientific thinking؟
ايه؟
scientific thinking.
Yes.
As we have seen in the previous video, almost everyone we interviewed did not know the accurate meaning of scientific thinking, and thus they did not apply it. We found that 85% did not know what scientific thinking is, and therefore they did not apply it. However, 10% knew what scientific thinking is, but they did not apply it, and only 5% understood the meaning of scientific thinking and applied it. John Gray is a well-cultivated scientific thinker who raises vital scientific questions and problems, formulating them clearly and precisely, gathers and assesses relevant scientific data and information using abstract ideas to interpret them effectively, comes to well-reasoned scientific conclusions and solutions, testing them against relevant criteria and standards, thinks open-mindedly with convergent systems of scientific thought, recognizing and assessing scientific assumptions, implications, and practical consequences, and communicates effectively with others in proposing solutions to complex scientific problems. John Gray is a psychologist and the best-selling author of Men Are From Mars and Women Are From Venus. Gray uses scientific method in his books to help you identify and take responsibility for the blocks to your personal success and identify needs and take actions. He also talks about how to get what you want and put your life together in order to achieve it. And all of this is based on the scientific method. In order to develop the skill of good decision-making through scientific thinking, we need to sharpen our capability and know what the elements of scientific thinking are and how they interact. Also, we should be able to construct appropriate articulation of these elements for different situations you evaluate in different fields. Another point to consider is the ability to think according to the scientific method and the nature of the problem at one hand, and not restrict ourselves to one method when we apply scientific thinking. Through the centuries, scientific thinking proved itself to be more productive than any other way of thinking. Everyone thinks. It is our nature to do so. But much of our thinking left to itself is biased, distorted, partial, uniformed, or downright prejudiced. Yet the quality of our life and that of what we produce, make, or build depends precisely on the quality of our thought. Shoody thinking is costly both in money and in quality of life. Excellence in thought, however, must be systematically cultivated. Critical thinking is the art of analyzing and evaluating thinking with a view to improving it. Critical thinking is self-directed, self-disciplined, self-monitored, and self-corrective thinking. It requires rigorous standards of excellence and mindful command of their use. It entails effective communication and problem-solving abilities, and commitment to overcoming our native egocentrism and sociocentrism. It is important to know that this disciplined way of generating knowledge is accessible to everyone, not only to a few experts. A way to do that is by spreading the word in universities and schools through committees or providing it through courses. For example, in AUC, all students are obliged to take scientific thinking as a course before they graduate, and this is a good opportunity to learn scientific thinking. In fact, the media should have a role in spreading the idea of scientific thinking. Actually, Egypt would really change if we applied scientific thinking in our daily life.
Science as we know it today began with scholars like René Descartes and Kevin Bacon. Francis Bacon. Not Kevin, Francis Bacon. They laid the foundation for modern science, the scientific method. First you see something happen, then you scratch your head until you can think of a reason. That's your hypothesis. It's a secret. Next you get to make up a test to see if you're right. If you are, it becomes a theory. If it's not, you have to go back and come up with a new hypothesis. And you'll repeat this process till you come up with something that works, or until you run out of money. Remember, it's got to be testable. I can come up with all kinds of explanations for things in my head. The lawn gnomes come alive whenever I'm not looking. But if your theories can't be tested by other people and have them get the same results, it just isn't science. Let's say you come up with a good theory and the scientific community likes it, because they have to like it. Now other people can start to use it, but it doesn't mean your theory is set in stone. Someone else could come along at any time and through better math or better logic or better data, show that your theory and conclusions are all messed up. You can end up spending your whole life working on something that's completely wrong. This can be uncomfortable. Needless to say, some people will resist and try to keep things the way they are, even if it means fudging the numbers or ignoring the truth. Oops. The danger is that in our society, science is thought of as fact. You need to understand that there are very few hard facts in science. Most of the science you read about, hear about, or talk about is theories. Now, generally speaking, scientists are fair and objective, and their theories tend to fit observable data. Unfortunately, there's a lot of science out there that isn't. Science. The science isn't science. It isn't science because it isn't provable. And yet scientists, teachers, politicians, corporations, and the media present some fairly loose-hanging theories as undeniable fact. Could it be they're pushing their own agenda? No. Yeah. Some scientists defend unprovable theories with just as much faith and blind conviction as any religious zealot. I mean, no wonder science is dubbed the new religion of the 21st century. String theory. I believe. Dark matter. Can you see the light? The Big Bang. Yes! Stuff like this can't be tested or proven. It's not science. It strays into the realm of philosophy, where proof is replaced by belief. That's why the creation debate is so heated between religion and science. It's all philosophical. You can't prove any of it. Now, I like science, and I'm okay with scientists believing whatever they want to. But if they can't prove something's true, it should never be presented as scientific fact. Sorry, guys, but you made up the rules. Believe it or not, there are some fundamental questions that science doesn't have any good answers for. It's okay. The scientific search for truth isn't about getting the answers you want. It's about finding the answers that are there. And finally, to all you non-scientific types, don't just accept what you're force-fed. So what if they're smarter than you? You can still question it. In fact, you should, because that is the scientific method.